All right. So I want to discuss a little bit about arithmetic sequences and geometric sequences. Since we're going into linear functions, it's only appropriate that we talk about arithmetic sequences. Now, what are arithmetic sequences? So these are patterns where you're repeatedly adding the same number. For instance, and here's an example down here. I'm kind of jumping a little bit, but I want you to follow this. So here's your definition right here, and it's a little homemade, and it's to help you kind of get an understanding of what I'm talking about. So the arithmetic sequence is where you're repeatedly adding the same number. So let's look at this. From 6 to 9, I had to add 3. From 9 to 12, I also added 3. From 12 to 15, I also added 3. And from 15 to 18, again, I added 3. So I'm repeatedly adding 3, so I know how I'm going to get the next number. I'm just going to add 3 to the previous term. So the number that we're repeatedly adding, we call that 3. That's our common difference. How do I find that? Well, if I subtract this term, if I subtract this first term from the second term, that'll tell me what my common difference is. 9 minus 3, or 9 minus 6, because the second term minus the first term, equals 3. That's my common difference. So the common difference here is 3. Now it's plus 3 because it's positive, but I don't usually write that unless unless I really need to indicate it. So why would I mention arithmetic sequences when talking about linear functions? Well, this just happens to be a formula that we can use to find a term in our arithmetic sequence. Okay. So a sub n, it's some random term in the sequence. So we're going to call that y. All right. D, that's my common difference. And remember from one of the other videos when we're looking at patterns here, okay, and I had 1, 3, 2, 6, 3, 9, and it looks like that's a little off. But when I had my pattern here, as I was going down, adding 3, what that really happened as I was going across is I was multiplying my x value times that common difference, and it gave me my y value. So the common difference here, it's what I'm going to multiply times my my term value, or the number in the x column. So here we have n is going to be our x value, and d, let's call that m just for the sake of familiarity. A sub 0, remember that was when I would go backwards and say, all right, 9 to 6, 6 to 3. So if I'm subtracting 3 going up, that means this right here would be 0, 3, 2, 1, 0. So it's what would be at the 0 term. So this, we're going to call it b, or for a starting value. This formula should look familiar. They describe exactly the same thing. They're labeled a little differently, but they describe a linear pattern. And a linear pattern, which is really neat, can be graphed, which some of you have seen. It can be graphed on an xy axis. So if this is x-axis, this is the y-axis. So I know that I have 1 to 3 right here, and I have 2 to 6 way up here. And it creates a very nice linear pattern. And those patterns are all over the place. Okay? Which is why this is very important to be able to identify and to be able to work with. So this was arithmetic sequences, and this is what we're going to be getting into with linear patterns. If you look over here at geometric sequences, we're going to do this in another unit, so it'll come up again. But a geometric sequence is a pattern where you're repeatedly multiplying by the same number. So this right here is our example here. And what I see here is 2 to 4, 4 to 8, 8 to 16. I'm just multiplying by 2 each time. So the common ratio is going to be the number we're repeatedly multiplying by. And there is a formula for a geometric sequence, a pretty standard one. It actually looks something like this. Y equals a times b to the x, where a is going to be our starting term, just like it was here, and b is going to be that common ratio. Okay, so that kind of gives you an idea of where we're going and why we're doing this, and hopefully gives you a little bit of connection to why we studied patterns so intensely in class, so that you can get used to going from a chart to a linear function. And then we're going to go from linear function and from the table to a graph, and vice versa. So this is going to be very intensely in depth, and we'll go into that with our next unit.